Thank you. All right. When I started, I said my talk has one theme and essentially three parts. So the theme is greatness is possible. Greatness is possible across the board, and greatness is possible measured by 2x, 4x, 10x better than what most people do, not just by 3%, 5%. So that's the theme. The parts are, how do you achieve greatness? Well, one is overcoming the challenge of complexity. All the different pieces, all the different disciplines that Ford has to worry about into the Ford Mustang, that a typical hospital has to worry about into the delivery of care. The complexity is the challenge. And when we said, well, what's the response to complexity? One is focus on process and systems, not just on individual functions and disciplines. So the talk we've gone through so far, the lessons people took out of looking at Toyota 1985, 1988, 1990, up to about 1993, 1995, in terms of how do you create a stable process in a chaotic environment, just of department, just of specialty, just of function. So that's where we are so far. But there's another part to this story. And the other part to this story is that creating a stable process is better than a chaotic process. But it doesn't get you to the performance Toyota demonstrated, which was introduce new models, introduce new brands, introduce new regions, introduce new technology, and on that way, dominate the world auto industry. So the question is, what's the other part? Well, the other part is, once you have a stable base, you have to use that stable base for continuous learning. And sometimes it's called continuous improvement. We can use the term innovation. We can use the term organizational learning. But the basic idea is that tomorrow, whatever work we do it better than we do it today. And in fact, maybe tomorrow the work we do is better work to be doing than the work we do today. However we want to label it is fine. So what I want to do is share with you two stories about two organizations which have demonstrated the capacity for improvement, innovation, learning, the dynamic aspect of achieving greatness. Now, I'm deliberately not continuing the Toyota story, and the reason for that is the theme of greatness is possible across the board. If I continue the story just with Toyota, then you say, oh, well, that's Toyota, but I don't do the work Toyota does. So let me pick two other examples. The chart you're looking at is very hard to read. I'll explain it. What this is a record of workplace safety at Alcoa, the bottom line, and U.S. manufacturing overall. Now, Alcoa is one of the world's largest aluminum manufacturers, so the work they do is extract bauxite in mining, very dangerous to do, take that bauxite and refine it, very dangerous to do, take the refined material, which is a compound of aluminum and oxygen, and smelt it, which is pump enormous amounts of electricity into something, release oxygen, make an oxygen-rich environment which has fire and combustibles around it, very dangerous to do. Then take the ingot which is formed and do things like roll it, so you have things which are big, heavy, massive, moving quickly. Extrude it, so you have things which are smaller and lighter but very sharp, moving quickly. But anyway, the work Alcoa does is very, very dangerous. I mean, it's certainly as dangerous as any work of anyone in this room. The way to read these numbers is it's a measure of risk. The risk of getting hurt on the job in any given year, wherever you happen to be employed. So for the U.S. economy as overall, from about 1990 to about 2000, the risk of getting hurt on the job decreased from about 4% a year to 2% a year. Part of that was structural, as fewer people worked in mining, manufacturing, and agriculture. For Alcoa, the chance of getting hurt on the job decreased from about 2% to, it says on the chart, 0.07% chance of getting hurt on the job. Now let me just set up what that means. 2% doesn't sound like a lot, unless you work for more than a year. If you work for more than a year, let's say 20 years, the chance of getting hurt on the job over your career at a 2% risk per year is something like 50, 60%. It means basically whatever your job is, you're likely to get hurt at some point. 0.07% means the chance of getting hurt on the job ever is well under 10%. So you take workplace safety or workplace danger, which is regular part of work, and decrease it to it's an unusual event. Now, notable in this, in these statistics are, one, Alcoa didn't change the work it does. 1987, it mined, it manufactured, it refined, it smelted, and so on and so forth. And 2000, 2001, it did the same work. Not only that, after the Berlin Wall came down, Alcoa bought all these plants in the former Eastern Europe, Hungary, the Czech Republic, Slovakia, East Germany, places which you wouldn't know. All right, so the thought association you typically don't make is dictatorial, repressive, communist regimes and the engineering done there and workplace safety. It doesn't go together. But anyway, Alcoa took over all these old mills and continued to improve safety. Now again, just one last sense of how safe this is. For my friends who work in the service industry, typically office-based work, they say, oh yeah, workplace safety, workplace safety. I say, well, you're in a job where once a year you change office location. I said, next year when you change office location in an office with 40, 50 people, if one person picks up one box of paper, does it incorrectly and hurts his back or her back, your on-the-job risk is worse than at Alcoa. One person moving one box of paper. So that's a sense of the safety there. The question is, how do you take very dangerous work and drive safety? So let me explain the story. 1987, Alcoa gets a new CEO, a guy named by the name of Paul O'Neill. And Paul O'Neill has his first press conference in a room probably something like this, and explains that as CEO, his number one concern is going to be safety. Not profitability, not market share, not revenue, not yield, not return on investment, not return on capital, safety. And his goal for safety is going to be not best in the industry, twice as good as last year, half the injuries as last year. His goal is going to be zero. His goal is going to be perfect safety. No one gets hurt who works for Alcoa. No one gets hurt who visits. No one gets hurt who's a contractor. Safety is the concern. The goal is zero. Now, the thing is, if you look at what was written about that press conference, most of the articles read something like this. Slightly different wording, but Alcoa has a new CEO. He has a, what's that? He has a, that's right. You know exactly where it goes. There's a new CEO. He has a very lofty ambition. But, of course, everyone knows that there's a trade-off. If you're more safe, it costs more money. If you're more safe, you have to work more slowly. So, obviously, if you want to be perfectly safe, it costs infinite money. Or, if you want to be perfectly safe, you can't make anything. So, nice guy, but an idiot. Well, in the period that Alcoa went from safer than most to the safest, Alcoa's stock price appreciated 8 times faster than the rest of its sector, 8 times faster than the rest of the industry, 8 times faster than the rest of the economy. The only thing that went up faster than Alcoa were the dot-com companies in that period, and this is before the bubble bust. Alcoa kept going, and you know what happened to most of them. So the question is, how do you get that nearly perfect safety, tremendous economic performance while you're digesting the industries of Eastern Europe? Paul O'Neill had several rules. The first rule was, if someone got hurt on the job, he wanted to know about it. But it got a little bit faster than that. If someone got hurt on the job, he wanted to know within 24 hours from the president of the business unit in which the harm was done. Now you start thinking, well, CEO of a major company, 90,000 employees at the time, he wants to hear about every injury. The first reaction is this guy is a control freak. But it's more than that, a control freak. Think about what has to happen. So 1987, I have to explain this to my students who are in their 20s still. I said, in 1987, if you're the president of a business unit and you're trying to call Paul O'Neill to tell him someone got hurt on the job, one, you have to find a phone. The younger people in the room are like, what's he talking about? The phones weren't in your pockets, they were on desks. And they were attached to the wall. And to call Paul O'Neill, you had to pick up the phone and actually dial it. It didn't have buttons. You dialed the phone, okay, and waited to see if he picked up on the other end. And if he didn't, you had to call back because there was no voicemail. I mean, all right, it's not quite Stone Age, but pretty close. It's kind of the system King David used, all right? You know, he's calling around. Right? No voicemail, no cell phone. Okay, there we go. So you're trying to call Paul O'Neill. So if you're business unit president, you have to reach him in 24 hours. It means you have to know in 18. And that means when you turn to your vice president and say, well, I need to know within 18, he's got the same phone problem and no email. So he's got to know within 12. And you get it down to the site manager, he's got to know within 2. And when you get it down to the superintendent, he's got to know within 15 minutes. And when you get it down to the first level supervisor, it goes something like this. If you hurt yourself, start screaming. Start right away. In fact, if you're not sure, start screaming. And not like little screams. We want like small child screams. Because if you don't start screaming right away, then I don't know right away, and that person doesn't know within 5 minutes, the next person 10 minutes, and so on and so forth. And you say, well, what's the point of this screaming thing? Well, it comes back to this problem of complexity. So you see within Alcoa, they hired the best manufacturing engineers, the best material scientists, the best process engineers in the world. They put them in a very resource-rich technical center outside Pittsburgh, told them to design perfect processes, and obviously they didn't. People got hurt. So the question is, if you hire very smart people, give them all the resources in the world, tell them to achieve perfection and they don't, you can't complain they're stupid because there's no one smarter. You can't complain they don't have enough time and money because you've given them infinity. All right, so there's more money than they can spend, more time than they can spend it, and they're very smart. So what's the problem? The problem is people get hurt because of things they hadn't anticipated in the lab. So this is guys pulling up a hatch on a big, what they call pot. It sounds like grandma's kitchen. But pot is about the size of the volume of this room. Opening up a hatch where you have molten metal. And as he's reaching in, the metal spatters out, and he has to jump out of the way to avoid getting hurt. We ask the question, why did it spatter? Why did he jump? No one designed it to do that. They designed it to be placid, to be nice and calm. The reason it spattered is perhaps there was a chemical impurity. Perhaps there was a change in voltage or change in current into the mix. No one designed that in. Then you say, well, why did he open it up? No one designed this person's work to open up a bubbling, boiling vat of molten metal. You just don't do that. This is where the 24-hour, the 18, 12, right away, scream right away comes in. Is that if you don't investigate right away, the conditions that created the problem disappear. So why does this guy open it up? Because he's wearing a face shield with one of those special visors on it. And he's looking in through another special field. And it turns out the window right here, there's a crack around the window frame. And coming in is a beam of light, which is bouncing off the shield, which is bouncing off his glass. And for a moment, not even a second, he's blinded. He doesn't even know he's blinded. It's so quick. But it's in that moment that he's looking in. He thinks he's seeing placid, flat, calm, metal. Turns out he's not seeing anything. Doesn't know that, opens it up. So why does Paul O'Neill have this 24-hour rule, which is really call the problem out right away? Is if you don't call the problem out right away, the sun moves. The impurity disappears. The voltage settles down. And when you call people over an hour later, even 15 minutes later, they say, what's wrong? It looks perfectly normal. The rule within Alcoa becomes, more generally speaking, you have to see problems as they occur. Because if you see problems as you occur, then as soon as you see them, you can start solving them while the problem is still fresh. Your knee is bothering you, swollen, inflamed. You go to the hospital now so they can see a troubled knee. You don't wait till the problem disappears and then say, 2 months later, can you tell me why my knee hurt? That investigation will yield nothing. Same thing here. Manage work to see problems right away. Why? Because whatever you invested in designing that work, you designed it wrong. And so if you know you designed something wrong, but you don't want it to be wrong, then you have to manage that work to see when it's wrong, where it's wrong, and then find out why.